Hi, welcome to Devtoberfest 2022. My name is Michelle Mowdy. I am a developer advocate here at SAP. I specialize in front-end development and popular front-end frameworks and their connection with SAP technologies. Today I'm going to be talking to you about RTK Query. This is built in with Redux Toolkit and is a way to simplify how you fetch data on the front end. I'll talk to you today about what RTK Query is, why you would use it when things like fetch and Axios already exist, how you would use it in actual code, and what else you can do with RTK Query. So the link to the repo that you see on screen, this UI React Redux samples, is where all the code is currently being hosted. If you want to follow along and code with me, you're going to want to switch to the data fetching main branch, as that is where I am starting from as well. It has all the code in the main branch, but with Redux Toolkit added to it as a good starting point here. I would also recommend installing the Redux DevTools extension for Chrome and Firefox if you haven't installed that already. This is because it will allow you to get a better idea on what's happening to your store as we go and mutate the state, along with what queries are being called and when. So what is RTK Query? It's an incredibly powerful tool built into Redux Toolkit, which is where the RTK comes from, that helps improve and simplify how we fetch data on the front end. It can do the same things as fetch and Axios, written in a much more elegant way, in my opinion, along with a lot more complex things with very few lines of extra code. One of the examples that I'll show you later, which is the one that I was most excited about when learning about RTK Query, is the ability to, with one option and one number, repeatedly query an endpoint, which can help in a number of use cases. Another really neat thing that I learned when creating this presentation was that you can fetch in multiple different places. And when you fetch in one place, it'll update in the other place as well. So you don't need to track if some data is getting updated and then immediately update it in the other place, or put it into the state. You can also very easily invalidate the data you have in the front end when you make a call to update the server, which is fantastic because you don't want to have out-of-date data on the front end. There are many more fantastic ways that RTK Query can help benefit us, and I'll go through those a little bit later in the presentation. For now, let's jump right into the code. Here's what the running application currently looks like. And I want to be clear here, I'm only really going to focus on where the API calls are made, so I'm going to leave out a lot of the functionality. We have two tabs, personal information and messages that work. We also have this notification bell down here, which has a list of notifications, the count of unread notifications, and when you click off of it and back, you'll notice the number went away, and when you click back on, they won't be bolded anymore. We also have these star icons here, which are clickable. It doesn't look like they do anything yet, but they actually are making calls to the back end. We just can't see them on the front end very easily. If we were to switch to personal information and back to messages, we would see that these are starred now, because every time we switch, we make the API call to get the messages again. And every time we get messages, we set our notification list to add the messages that we haven't seen yet. And this will all be more clear as we code along. So there are a couple problems with the application as it's currently implemented, and I want to be clear that these could be solved without RTK Query. It's just so easy to do with RTK Query. I wanted to demonstrate that. So the current problems are: the first one is obviously when we click these, we don't see an update on the front end. We have to switch to personal information and back to messages to see that update. The other thing is every time we switch tabs, we make another API call, even if messages isn't even on the screen, which is not exactly the behavior we want. Another thing, the only time the notifications list ever actually updates is when that API call is made, so when we switch tabs. Typically, the behavior you want for notifications is for those to pop up and update periodically over time, regardless of what's on screen. We don't want to have out-of-date data in that notifications list until we switch tabs or the user does some kind of action, because it could be a really long time before that happens. We want to be able to set the interval that that notification list is updated. So we will start solving these problems by adding our RTK Query API and adding our first endpoint, the simple GET call that grabs all of our messages. We will put them in the exact same places they are now, and then we will start to expand that by changing how and when we call that API. Then we'll update our notification list, and I'll show you how to repeatedly query the same endpoint, which will update our data in multiple different places, which is very exciting. From there, we'll add our second and last endpoint, a put call, and I'll show you how you can expand that so that every time we call that endpoint, we make sure that the front end is updated. This way, the front end is always dealing with the most up-to-date data as we know it. So let's start by learning how to run the application. The first step after pulling a new repo should always be to run a yarn install. Mine are already up to date, yours might not be, so just make sure to run that and wait for it to finish before you move on to the next step. The next thing we need to do is run yarn server. This is because we are making API calls, so we needed a backend, and I used JSON server and NodeMon to create a mock backend for us to use. Now we need to actually run the application itself, and I'll do that by just running yarn start. If you ever forget these commands or want to know more about which ones are available, you can always look at package.json. This will show you all of the scripts that we have and is a good reminder if you've forgotten, which I do frequently. As I said before, the first thing that we're going to do is we're going to set up our API and our first GET call. So the first file we want to look at is app.js. That is because this is the file that holds our get messages fetch, along with the main content for both personal information and messages. And if you'll notice here, I've actually set this up to use fetch, but we'll be replacing that with the RTK Query API, which is our first step. So to do that, I need to create a new file in this API folder that I've already created, and I'm going to call it Messages API. Please note I will be copy and pasting a lot of code. That's just to save myself time, but I will point out the important bits of the code as I go along. So let me go ahead and grab the first part of the code that we need for the API. So to get started, we are using the create API function from RTK Query. This one is specific for React because they utilize some React hooks in it, but if you're not using React as a front end, be sure you're not using the React specific create API function. I named it API messages just because that matches the file name, and let's get started creating our configuration for this. The first thing we need to do is write our reducer path. This is because RTK Query is built on top of and into Redux Toolkit. So this path is used to register the API into the store. It has a default of just API, but we want to be a little bit more descriptive, and I'm going to call it Messages API. The next thing we need is our base query. Now this is what our endpoints are going to be appended onto, and it contains all of our base options. If you want to add headers, which you don't need to, or any kind of options that you want every single one of your endpoints to have, this is where you would do it. And it's in the base query parameter, and I'm going to use the function fetch base query. And this is coming from the same place as the create API function, and it holds an object of all kinds of options. Now you need a base URL. It does default to the base path of where the API is called from. They really don't recommend that and typically want you to add in your own base URL here. I'm going to do that because our JSON server is running on a different port than the application. So we do in fact need to specify this. The last thing that we need just to set this up is our endpoints. This is a function that gets sent this build parameter, and that is used to create all of our endpoints and functions. Our first endpoint is going to be get messages, and it's going to use a function off of build called query. Now there's two types of functions that I'm going to be using today, the build.query and the build.mutation, which I'll go over later. Build query is what you would use for all of your get requests. It takes in an object that requires a query, and this is the rest of your URL, the rest of your endpoint that you're going to be making this call to. It is a function that can be sent a parameter. For this one, all we're going to do is grab every single one of the messages, so we just need the messages path. And that's pretty much all we need to do to set up this API. Now that the API has been created, we need to connect it to our store. If you've seen my previous presentation on Redux and Redux Toolkit, the store should look familiar to you. But if it is unfamiliar, I would recommend watching that presentation so you have an idea of what's going on. The first thing we need to do is add our API to the reducers. This is because RTK Query is directly built into the store and has its own state. And I'm going to go ahead and just copy this in here. The next thing we need to do is set up our middleware. And I'll do that by just getting the default middleware function and concatenating it with the messages API middleware. If I save this, our application will re-render, and we can see our new changes and our API in our store, and you can see that the middleware was registered. So if you take a look at our state, we have our app, profile, messages, and now messages API, which is wonderful and exactly what we want to see. Now that we've got that set up, let's go ahead and start using our API now. The first thing we need to do is we need to export our endpoints. So export const, it's an object from messages API. And one of the things you're going to notice as I type this is that the API actually prepends all of the endpoints with a use and appends it with either query, as it is in this case, or mutation, as we'll find out later. So just keep that in mind as you're writing your endpoints. Now let's go ahead and go to our app.json file where our get messages function is, which fetches and returns the messages and sets it in state. So one of the benefits of RTK Query is all of this is actually now in the messages API, all except for this right here. So what we're going to do is call our useQuery function and grab the data out of it. And this line right here is actually the equivalent of these two lines here, but without the need to await or process our returned data. So we don't need to JSON it because it already returns that way. It's just already done for us. Now, because we do want to dispatch these messages into the state, I'm going to go ahead and reuse this use effect, but I'm going to remove all of this code. Well, I'm going to copy this and then remove all of this code and paste it there. I'm going to remove this. And now this is all set up and ready to go. And if we save this, we will be able to see this function being called. So as you see here, we have our middleware is registered. We have a set messages, which has this. We have a pending, another set messages, which is empty, and a fulfilled, right? So our state now looks and has an empty messages. That's not exactly the behavior that we want to have. This is because there were two dispatches called. This is because there were two dispatches being called before the API had even returned the fulfilled status, which means that it had been completed. So we're going to go ahead and handle that. We're going to do that by adding another one of the returned variables provided by the API, and that would be is loading. So this variable here is essentially true only the first time this API is called when the component is rendered. So if isLoading is true, the API call hasn't been completed and we don't have data yet. So we can use that to say, if it's not loading, then dispatch our set messages. And we also want to make sure that this is called every time isLoading is changed, right? So if we save this and we refresh, we'll see now that we have a pending, fulfilled, and then set messages is called. And if you see the diff, we now actually have messages in there, which is exactly what we wanted to see. But there is another problem. If we go to messages and we go back to personal information and back to messages, we never end up calling our API again. And every time we go back to messages, we always want to have the most up-to-date data. So to do that, it actually makes the most sense to move it out of the app component and into the messages component. So to do so, we're actually going to remove all of the code that we just wrote, because it doesn't need to be here anymore. Right? We'll remove all the unused imports because they're not necessary. We'll save. And let's go to the messages component. So if we are grabbing our messages from the backend directly in this file, we don't actually need messages from our state anymore. So one of the things that we're going to do is remove all of this from our messages slice. But let's start by just adding the API call, right? We'll import the function and we will remove the Redux state and the unused imports. And because I like to clean up my code, we're going to go ahead and also remove all of this from state as well. We don't need to set the state anymore, and we don't need this use select messages selector anymore, right? And now this set messages reducer is only actually setting the notifications, so we're going to rename that as well. Save that. And that'll help us a little later on. So if we save this and go to our application, refresh, go to messages, you'll see that the middleware has been configured now only when messages was loaded, because it doesn't need to be configured before that. And we're going to have our pending and fulfilled, which is great. But the problem is that if we go and update our backend with new data and save it, we will not actually end up getting that new information. And that is because of the way RTK Query caches data. If you see here, we have this unsubscribed, and then we went back to messages, and the API execute query was rejected. That is because it has been less than 60 seconds since this data was added to the state. Now, if we move off of personal information and we're unsubscribed, so there's no subscribers to this information anymore, and we wait 60 seconds, we will be able to see the data expire, and when we move back to messages, we will be able to refresh it and grab new data. And I'll speed this along in the recording. Okay, so you can see here, 1 minute after the unsubscribed, we have this queries remove query result. Now, if we go to messages, we will actually have the pending and fulfilled. But for our needs, I'm going to show you how to actually force this to go and fetch new data every time this component is mounted or the arguments change. So we're going to go back to our messages. And I'm going to add an object of options to our query function. Now, it is important to note here that if you don't have anything being sent into the endpoint itself, you'll need to start it with undefined. If we were sending in an index or some kind of value that would be used to create the query or used to modify the returned data in some way, then we wouldn't have to do this. But because there is nothing being sent in, we want to make sure that our object is actually being added to the correct value. So undefined. And then we're going to have an object. And the value we want to use here is called refetch on mount or arc change. That means that when this component mounts, we want to refetch the data. We want to recall this API. And I'm going to format the file, save, and you'll see a difference in behavior now when we move from personal information, messages, and back again. So we're going to go to messages, we'll get our first one, move back here, and then we'll move back to messages, and this time it did actually recall the API, which is great. This does give you a lot more control over how many API calls your application actually makes. With us, our data is small and it's all local and it's mocked, so it doesn't really matter, but with much larger applications that may be stored in the cloud and you pay per call, this can be really, really useful in having more control over everything. So, if you've noticed, the notifications bell has had 0 here, and there's been nothing in the list. That is because we removed where and when we were adding the messages into the state and updating our notifications list. So let's go ahead and get that set up now. And our notifications live in app header. As you can see down here, this notifications pop over. And so we're going to start by grabbing our data here and updating the state. I'm just going to go ahead and copy and paste this. Add our import. And I'm going to add the use effect that's needed to make this update our notifications. Right? Going to save this. If we go look at notifications, you'll see we ended up having the exact same issue that we had before, in which the dispatch is being called before the data is actually ready. So we can do the same thing here. Add is loading. If not loading, run our dispatch. I'm going to format that so that it's a little bit easier to read. We're going to add our is loading here so that every time this changes, we rerun this use effect. Save, and we'll see that we're now getting data. And this is fantastic. This is exactly what we were looking for. So one of the things we want to do is we want to make sure that notifications is updated periodically at an interval that we choose. And we can do this very easily with something called polling interval. It's another one of the options in that array, just like the refetch on mount or args change. So let's go set that up. Undefined. Again, because we're not sending anything into our get messages function, we're going to have our object and polling interval, and polling interval is defaulted to 0, which means that there's no polling interval and it won't call it any time other than the first time, or when we set up some other kind of flag to recall it. And it's done in milliseconds, so if we wanted to do it every 3 seconds, we would do this 3000. If we save, we'll move back over here. We'll refresh just to restart the store. And you'll start to notice that every 3 seconds, we're calling this API again. But if you'll notice, it's not calling the use effect, and that is because that is loading variable we have only changes the very first time this API is called. The variable we actually need for something like this is fetching. So now you'll start to see it's going to set the notifications, which is fantastic, exactly what we wanted. So now we've added this same query, the same get messages query in 2 different components, notifications and in messages. So I'm going to show you something that's really cool. I'm going to set this to a longer interval, 10 seconds, save that. I'm going to update our backend with another message. I'm going to save, and this hasn't been called, and it won't be called, and I'm going to move to messages. And if you notice, we called the API when I moved to messages because we had it set to refetch on mount, right? It wasn't quite time yet for the notifications to refetch the data. But as soon as we moved to messages, we refetched the data and updated the store because of the fetch done in messages, which means that if you fetch data in one place, every other place that that data is read will be updated at the same time. So this is really convenient because you don't really want to have to fetch this data in one place, put it in the store, and then grab it in the other like you would with just Redux. Now it's all handled out of the box with RTK Query, which is really convenient because for something like notifications, you don't want it to be behind just because it hasn't hit its polling interval yet. Your polling interval could be something like 5 minutes, but if you go to messages and you notice that, oh hey, there's already new notifications, those should be shown in your notifications bell. And it was handled without any configuration from us. So the next thing I'm going to show you is a mutation, and that's any of your posts, your puts, your deletes, any of those kind of calls. And we'll do that by updating the code that we have for this star. So it does make calls to the backend, it's just very slow. When the notification bell ends up refetching, these will update, which is great and exactly what we want, but it's not the best experience to have it take so long for that to be updated. If this was me, I'd be clicking that star a million times wondering why it hadn't updated yet. So let's go and put that in RTK Query, and I'll show you how easy it is to actually update that. The code for this server update call is actually in our messages list item. This is the component that holds each of the individual items in the list and that little star. And you can see the call here. right? We have our request options, which is put, our headers, the body, which we have to stringify, the headers, which is application JSON, we have our ID and body, and then we have to await our response. And as of right now, we're just logging that response so that we can see that it's actually being run correctly, since the UI doesn't update very well. So let's start writing our mutation. It's going to go into the exact same place as our set messages query. And we're going to call it set messages starred. It uses the same build as before, but instead of query, we're going to use mutation. We also need a query to tell it which endpoint to use, but unlike the get messages query, we're actually going to have some input variables. We're going to have an object that has ID, and we're going to have a body here as well. So very similar to how the messages list item had its request options, we're going to do something like that here with this query. We're going to have our URL with messages and our ID. We're going to have our method. And we're going to, instead of JSON stringifying our body, we're just going to go ahead and spread our body again. If I could spread that correctly. I'm going to go ahead and format this file, and then I'm going to export our set messages starred function in the same way we did the query, except instead of it ending in query, it's going to end in mutation. See? Set stars messages mutation. So I'm going to go ahead and move this back since we don't need to look at that anymore. And now what I'm going to do is I'm actually going to replace this entire function with a single line. I'm going to remove this and start writing. One of the things that's a little different with a mutation over a query is that you don't just automatically get the data. You actually get a function that you can use anywhere else in your component. And it's got the same name as what we set in our API. So in this case, it's going to be set messages starred. And it's going to come from our use set messages starred mutation. This can also return an object of options and return values, just like we have our query, but that would be here in the second parameter here. We're not going to use any of that, just wanted to point that out in case you were wondering if there was more stuff that you could get from this mutation. And now we're going to take this, and we're going to go ahead and replace this handle toggle starred, save, come here into messages, and now we will see our stars being executed, which is exactly what we want, except we're not seeing our UI update until our notifications refetches the data. There's a really simple fix for this. RTK Query works on a cache. Just like we saw when we had to add the refetch on mount parameter to our messages get call. One of the things you can do is add a tag to your queries and invalidate them with mutations. And this allows you to say, hey, I've updated the backend with this mutation. So please invalidate all of the cached data that you get with these queries that have this tag. This way you know that any information you have on the front end is always the most up to date. And all you need to do to set this up is add 3 lines of code to your API. The first thing you need to do is you need a global tag list. These are essentially tags that you're going to use in any of your endpoints, and you need them to be in this global tag types array. There can be any number in here. The names of the tags don't actually matter. You can decide all of that yourself. So the next thing we're going to do is we're going to provide a tag for our query. And that's the provide tags parameter with an array of tags. And you can have any number of tags here. And then the last thing we're going to do is we're going to say, hey, our mutation needs to invalidate all of the queries that use this same tag. So it uses the invalidates tag array and messages. The best part here is you can have one mutation invalidate multiple tags, or one query with dozens of tags, and they can mix and match, and you can have the same tag on multiple queries or invalidate the same tag with multiple mutations. So I'm going to save this. And we're going to go to messages, and I'm going to click this button, and we'll see now that the UI updated immediately. And this is exactly the kind of behavior that we want to see. And so with that, we've added all of the RTK query code I wanted to show you today. We figured out how to write a get call, a put call, and some of the options available to you directly out of the box, easy to access with RTK Query. However, this isn't all that RTK Query is capable of. I've touched on a few of these points here and there throughout the coding, but it's always worth it to go over these again and in more detail. RTK has automatic loading and fetching parameters, and we saw those when we added the handling to make sure that the dispatch for the state is only called when the API call has been completed the first time. And then when we added the is fetching for the notifications bell. These can be really, really handy when you want to do something like set up a loader or a spinner the first time a component is rendered, but then after that, all you want to do is gray out the data that's already there to say, hey, this data might not be valid, don't touch anything for a second. Some other things is you no longer really need to write try-catch blocks. Just like is loading and is fetching, there's an is error and the error message itself that can just be accessed in those same ways. This means you have a lot less boilerplate code that you need to handle, which means less for you to maintain yourself. There's also built-in support for optimistic rendering. Now, when we were looking at the favoriting and unfavoriting of messages, we handled that by just invalidating the cache. We had zero latency in the return of our API calls because our data was mocked on a JSON server, but sometimes there can be a delay of seconds, and we don't want to just wait on the front end for that response to come back saying, hey, it's cool, here's your new data. Instead, we can set up the optimistic rendering to say, hey, we expect this update function to complete correctly, so let's already show it on the UI. Then there's no need to wait, and we'll get the exact same user experience without having to wait for all of the other backend calls to complete. And just like Redux, RTK Query is UI agnostic, which means you can use it with Angular, React, Svelte, and combine it with all kinds of libraries like the UI5 web components. This means that it is an easy choice to make when you're looking for a state management and data fetching tool. So thank you for watching. I hope you've been able to learn more about RTK Query and what it is and why it might benefit you in your front-end development world. If you have any questions, feel free to reach out to me on Twitter or LinkedIn. You can also leave a question in the comments below and I will try to answer it. Thank you again and happy coding!